All right, ladies and gentlemen, welcome to Chapter 6. Chapter 6 is going to be a lot about solving equations. And so we're going to start with some of the basics of solving an equation. In Lesson 6.1, you'll notice here we're going to solve equations by adding and subtracting. Two main goals of this particular chapter. One is, can we determine whether values are solutions to an equation or not? And then two, we're going to practice or show how we solve some simple one-step equations using addition and subtraction. So let's start with the first thing that we usually deal with is some of the vocabulary. First of all is an equation. An equation is a mathematical sentence that shows two expressions are equivalent to each other. So in this particular case, you'll notice I have a couple examples. The first example, 2 plus y equals 10. Okay? That is telling me that these two values, when I add them together, they are equal to 10. And I hope everybody realizes at this point that y is equal to 8. And this is one of the types of equations that we are going to solve in this particular section. Okay. Now another type of equation, and this again is just an example. 13x squared minus 2x plus 3 equals 12. So this equation is saying, let me change... This equation is saying that all of this stuff here, added together, multiplied, and so on, is equal to 12. Now, yes, there will come a time where you will solve this equation and figure out what is the value of x, but that is actually, in this case, it's for a later date. When you get in Algebra 1, you'll get into solving these types of equations. Okay, we're going to deal with some of the basic equations in this particular case. Now in solving an equation, we're going to deal with inverse operations. And those are, and this is not a mathematical definition, you're not going to see this one in a textbook. Operations that undo each other, opposites, like addition and subtraction. How do I undo addition? Well, I subtract. How do I undo multiplication? I divide, and so on. And so we're going to have to work in inverse operations and think, well, what is the operation here that undoes this particular thing? Okay, so now first of all though, we're going to go ahead and we're going to determine whether a number is a solution of an equation. So our equation is x plus 8 equals 17. We're going to determine whether 8 or 9 is a solution, and I hope that you know at this particular point that 9 is the solution. But let's go ahead and pretend for just a second that we don't know. Over here are my steps, okay, and I'm actually going to start with 8. And the first thing is to substitute. So I'm going to take 8, and I am going to substitute it into the equation for x. I'm going to change x to 8. Now I'm going to go 8 plus 8. Is that equal to 17? If it is, it's my solution. If it's not my solution. Well, 8 plus 8, okay, this is the second part, simplify. So 8 plus 8, that's 16. Well, is 16 equal to 17? Well, that is and that would be again a question. Well, the answer to that is no, it's not. So 8, since both sides are not equal, is not the solution. Okay, let's go ahead and do this again. Let's pretend that we don't know 9 is the solution. I'm going to take 9, I'm going to put it in for x. Okay, so in this case, I've got 9 plus 8. Does that equal to 17? And I'm going to simplify. 9 plus 8 is 17. Well, since 17 equals 17, hey, we're golden. That one works. So my solution is obviously 9. And again, this was a simple example. Let's go to one that's a little more challenging. 2y, 2 times y minus 4 equals 16. Our choices are either 5 or 10. Well, just like the previous example A, we're going to follow our steps. So I'm going to start with 5, and I'm going to put it in for y. Okay, now notice no space means multiply, so when I write this out, I'll use parentheses in order to show my multiplication. I need to keep that multiplication. Okay, and so is 2 times 5 minus 4, is that equal? This is supposed to be a little question mark. Does that equal 16? Well, multiplication before subtraction, so 2 times 5 is 10. Doing that part first, minus 4. Still checking, is that equal to 16? Well, 10 minus 4, that's 6. Well, 6 is not equal to 16. So, not a solution. At least 5 is not a solution. So let's go ahead and check and see if 10 satisfies this or not. So I'm going to put 10 in for y now. So I've got 2 times 10 minus 4 equals 16. And we're again checking to see are these equal. Well, 2 times 10 is 20. And 20 minus 4 is 16. Does 16 equal 16? Well, you bet it does. So my solution in this case is 10. Okay. And again, here are the steps for when you're just simply trying to determine whether a solution is an equation. This is what we do to check our answers when we're solving equations. Once we have an equation, or have a solution to an equation, we should substitute into the expression and see, do we get balance. Speaking of balance, for those of you who had Mrs. Vogt in 6th grade prior to coming to 7th or 8th grade, or pre-algebra, depending on what class you happen to be in, you, I'm sure, are familiar with hands-on equations. Now, you can use hands-on equations, although I don't give them out in this particular point, but you can still use the idea to help you in the beginning to solve equations. Now, we're going to start with a very basic equation, and I'm going to show you in hands-on equations, using the drawing technique down here. And I'm also going to show you how algebraically to solve this equation. Again, I hope you know that this is a 6, and I chose an easy one so we know what the answer would be. It's the algebraic steps that I want you to be able to show. So, okay, if we were going to set this up using hands-on equations, let me go ahead and set this up. And I'm going to go ahead and get all of my pieces out here, and I'm going to fill them in. So we would have a cube value of 8. I'm going to fill that in here. We would have, in this case, t, or it's x in hands-on equations, but our variable. And then on the other side of our balance is 14. And your job in hands-on equations would be to figure out what is the value of x, or in this case, t. Well, do I have x's on both sides to remove? The answer is no. So I would then go the next step and remove 8 from both sides. Okay, and you very literally, if you had the hands-on equations, you would take this off and put it somewhere else. And then over here, you would go 14 minus that 8 that you took away is 6. So we found out here that t is equal to 6. Well, we're going to do the same exact thing up here. Okay. Now this is my little equal sign. So, and if this helps you, some people like to do it. Okay, that's where this little thing comes from. And we are going to get our variable by itself by removing, in this case, the 8 from both sides. Now, so we're going to write this down. We are going to literally go 8 minus 8, but we're going to do it from both sides of the equations so my little balance doesn't tip. Well, if I go 8 minus 8, well, those cancel out. My t is left on this side of my equation. I'm going to bring my equal sign down. 14 minus 8 is 6. So you'll notice t equals 6. Now we're going to check it. Okay, and to check it, actually let's get an actual writing utensil. We're going to do what we did on the previous slide. We're going to take our solution, we're going to put it back into the original equation for our variable, and we're going to simply check, does 8 plus 6 equal 14? If it does, we have the correct solution. 8 plus 6, well yeah, that's 14. If it doesn't end up being equal, then we have a problem somewhere. Oh, sorry, 14. So it checks out. But if it didn't, if these did not end up being equal, we need to go back and figure out what mistake we made and where. Alright? So now we're going to do this without the hands-on equations. You'll notice, though, I have subtraction. Okay? But again, here, right here, this is my little balance point. Okay? For my hands-on equations. So I want to isolate the variable. So I'm going to, this would be right here, this would be my cube. Now I know you're not used to using a negative, but think about it here. This would be my cube. This would be my cube. All right. Now I'm going to go ahead and get rid of those because I don't want the cubes. But we want g by itself. So you have to ask yourself, what can I do to negative 13 to get it to go away? What is the opposite of minus 13? Well, the opposite is plus 13. Right? Negative 13 plus 13, well, that's 0, and these things would cancel themselves out. So I'm going to do that to both sides so that I keep my balanced equal sign. That's this long equal sign. Well, the g comes down because I haven't gotten rid of it, and then I'm going to go 8 and 13. Well, that's 21. So I've just found out that g is equal to 21. Now we do want to check it. Let me change colors here. I'm going to take my 21 and put it back into the original equation. I'm going to replace g with it and check, does 21 minus 13 equal 8? If it does, my 21 is the correct solution. If it doesn't, my 21 is not the correct solution, and I need to go back and try something else. Well, 21 minus 13 is 8. Well, 8 does equal 8. So I have a good solution. G equals 21. Okay. So we're going to work in inverse operations. Do the opposite of what's currently happening in the problem. So in this particular case, again, if I really wanted to do this, not that I want to, but there's my x, or my variable, 12, negative 16. Okay. But again, I want to get away. I want to get rid of this. Okay. So now, I want to isolate my variable again right here. That is the left side, right side. So what do I do to plus 12 to get it to go away? Well, I do the opposite of plus 12, and that's minus 12. So I'm going to subtract 12 from both sides. And again, if you were to do that here, what would you do? Well, you would take 12 away, and you would get rid of that, and then you would have to figure out how to take 12 away, which this is where it becomes tricky with hands-on equations, okay? And that's where the math part of it, and this is why I want to get rid of the hands-on equations, because the math part actually ends up being simpler in the long run, as long as you know your rules. So positive 12 and negative 12, well, those cancel out. The p, the variable, is still left over here, so I'll bring it down. Negative 16 and negative 12. Now, some people are going to try to go negative 4. It is not. Two negatives, add them together, make them into a larger negative, negative 28. So p equals negative 28. But I need to check it. Let's double, especially in this case, let's go ahead and check it. Because those people, and this is where the checking comes in. If let's pretend for a second, if you went 4, you would end up with 4, when I check it, 4 plus 12 equals negative 16. Well, is 4 plus 12 negative 16? No, it's positive 16, so it can't be 4. And that's why we check it, okay, to make sure that we're correct. So, okay, negative 28 replaces p. So negative 28 plus 12. Is that equal to negative 16? Well, subtract them. So 28 minus 12 is 16. You are going with the larger sign here, the negative. Negative 16 equals negative 16. Voila, there we are. All set. Good answer. And that gets us to the end of the section. Okay. Time for your practice. And please, please, please come see me if you have any questions, or when you have questions, because I know they're going to come up. So, good luck.